Let's Get Ramped Up is a lesson designed for kindergarteners. I've found that kindergarteners have a keen interest in automobiles, moving parts, the simple tools that surround us, and the workings of the world. Ramps are a perfect way to gather all these interests together into a lesson that tackles STEM, also known as science, technology, engineering, and mathematics. This lesson is intended to address one of the simple tools common to man, the ramp, as well as concepts such as gravity, energy, force, and friction. There are less people in the American culture searching for jobs in the areas of STEM, putting us behind other countries in development and forcing us to outsource for jobs we could be doing here. By introducing STEM to our young children, we are creating lifelong learners with a passion for solving problems and developing ways to meet the needs of our ever-changing world. The best way to do this is to find a topic that students already have a stake in and help them to develop the problem-solving skills and ingenuity that surround the concepts found in STEM. In order to encourage this learning and provide students with a stable base, we should consider using the 6E lesson plan model. The 6 E's stand for engage, explore, explain, engineer, enrich, and evaluate. Engage, the first stage in the 6E model, is used to activate prior knowledge. Students are assessed on what they already know, and this provides an opportunity for them to share this with one another. During this stage, the teacher will also work to focus student interest and engagement to the topic at hand. Kindergarten students are beginning to explore both two-dimensional and three-dimensional shapes. Using Let's Get Ramped Up, the teacher can tie in geometry by first presenting a right triangle and asking students to name the shape. After presenting this two-dimensional drawing, the teacher can hold up a block in the shape of a wedge. The teacher should pass this around the classroom so that students can see it from all angles. As it is being passed around, the teacher can begin to describe how these wedges are used, what they are called, and how they tie in with the idea of a ramp. Once everyone has seen the block, the teacher should present students with a picture of a ramp in a setting from everyday life, such as a truck ramp or a ramp seen at a department store. The teacher may print out various pictures for each student and ask them to circle the wedge shape or ramp that they see in the pictures. Students are now ready for the explore stage. In this stage, students are working more closely with the concept. They may be paired up to discuss and think through the new topic that has been introduced. The teacher should facilitate discussion at this point and encourage student thinking by asking questions. To begin the explore phase of this lesson, it is a good idea to integrate some literature using the book Roll, Slope, and Slide, a book about ramps by Michael Dahl and Denise Shea. This provides an alternative way for students to view ramps in a fun and exciting way. In addition to the book, the teacher may present students with a toy Hot Wheels ramp, the game Mousetrap, or a simple homemade ramp. The teacher may ask students to come up with other ways a ramp can be used and where else they have seen ramps before. This can be done in small groups of about 4. Once everyone has completed their discussion, the students can come back together and reveal their findings. The teacher can provide additional ideas if the students overlooked any. To integrate technology and family involvement, ask students to take pictures of the ramps that they see as they run errands with their parents or guardians. Those that do not have access to a camera can search for pictures online during school hours. At this point, students should be ready for the explain phase. Here, students will discuss what they have learned and observed, and they will communicate with one another about these concepts as a class. Students should be given the opportunity to collect pictures of ramps and bring these back to the classroom. Once a few days have passed, students should present their pictures. In each picture, the students should describe where the ramp is, what it is used for, and how it is used to suit the needs of the human being. The teacher should ask questions such as, what does this ramp do to make life easier? Is there a better way to position this ramp? What do you think would happen if this ramp was steeper or created more flat? Give students time to think about these questions and listen to answers to gauge understanding. Now it is time for students to engineer. In this stage, students will be given the tools and materials to develop their own design and test them to see precisely how they work. For this lesson, materials are fairly simple. Students should be given blocks, textbooks, rulers, wood, scrap metal, and cardboard. Students should be allowed to use objects they see around the room as well to wield their own ramps. Also, provide a variety of vehicles, masking tape, pencil and paper, and a small kitchen scale or 2 for the classroom. Students should pick their vehicle of choice, weigh this, and write it down on a piece of paper. They should then break into partners and build their ramp side by side. The goal here should be to see whose vehicle can go the furthest. Ask students to predict whose vehicle will go the furthest. Have them do 5 runs together, making adjustments to their ramps each time. Students should mark off where they are dropping their cars from on the ramp. They should be marking off how far their vehicles go with masking tape on the floor as well, and labeling these 1 through 5, coordinating with each drop. As they run their vehicles down their ramps, they should be marking whose car went the furthest on their paper by placing a check on their paper for each time their vehicle passed their partners. The 5th E in this model stands for enrich. Students are now ready to transfer their explanation and designs to a real-world application and make some predictions about new questions posed by the teacher. There are so many ways to enrich this lesson. The teacher may ask students to note the weight of their car and their partners. They should evaluate whether or not the weight factored into the distance the cars traveled. Are the materials a factor in how far the cars traveled? Encourage students to feel the cardboard and the sheet metal. They should take note that the cardboard is more rough, causing more friction, which may slow the car down. Did their partner drop their car from a higher point on the ramp? If so, did this affect the distance the cars traveled? What would happen if a car traveled up a ramp instead of down? How could we decrease the distance the car traveled? Explain that there are ramps on the highway for runaway semis. A semi who has lost control can travel up these ramps to slow them down and prevent a crash from happening. At the top of the ramp, there are rocks. These rocks cause friction, which also decrease the speed of the semi. Explain how the ramp helps to ease the speed slowly so that there isn't excessive force that would smash the front of the semi. Provide an activity for students using the ramps that may be a little more challenging. Place a string in front of the masking tape that traveled second longest from the ramp. Ask students to adjust their ramps and the point on which they drop their cars from the ramp to see who can get closest to the string without passing it. Give them 3 attempts. Students will see how energy increases as the slope of the ramp is increased and with the height the car is dropped from. Students may do 2 more drops, this time using materials they find around the classroom to cause friction and slow the speed and distance of their cars. Evaluation of students should be the final step in the 6E model. This stage is used for the teacher to assess student learning and for students to self-assess. Assessment should be both formative and summative. Formative assessment should be ongoing and done through questioning and observation throughout the lesson. Summative assessment should be done using both a rubric and a series of questions intended to encourage higher-level thinking. Problems a teacher should pose may include draw a ramp and state its shape. Define what a ramp is and what it is used for. Would it take more energy for a person to roll a ball up a set of stairs or up a ramp? Compare these 2 ramps. If the same car were dropped off these 2 ramps from the same height, which car would go a further distance? Predict what would happen if there were no force or energy behind a car that was trying to go uphill. Draw the best ramp for people to get in and out of the store in a wheelchair. List your materials and explain why you chose them. This lesson is easy to differentiate for different learning levels. You can go as much into any topic as you would like and provide support and assistance where you deem necessary. Questions and problems can be as intricate or as simple as your students need, and students can support one another as they try to work through their problems and challenge each other to come up with the best designs. Students can get a lot out of this lesson with minimal safety issues. The biggest concern is an awareness of space. Students should be cautious and considerate of the cars and ramps around the classroom, as these could cause tripping hazards. Make sure scrap metal does not have any edges that could cut a student, and students may use scissors for masking tape. Ask that they carry their scissors downwards and emphasize that they should not run with them.